So now this video is going to be another test of the Zener diode. This is not a how-to for using Zener diodes, by the way. I pretty much assume you already know how to use them properly. We're just going to look at how to do a test to test their Zener voltage. So in this case, the power supply here, we're going to limit current to 5 milliamps of current. So 5 milliamps of current can never, more than 5 milliamps of current I should say, can never flow through the Zener diode. That is important for this test. We're going to take the Zener diode and connect it directly to the power rail. So it's a 9.1 volt Zener diode, and so it's not going to conduct yet. The cathode is to the positive rail, the anode to the negative rail. Cathode has the black stripe. It is reverse bias, so it's not going to conduct until about 9.1 volts. So let's start raising it up to 9 volts. There you can see there's no current. If we set this to show voltage, we see 9 volts right there. Now let's raise it to 10 volts. It's a Zener diode by itself. It is conducting. It's blocking about 9.3 volts at 5 milliamps of current. If we lower the amount of current, you'll see it starts blocking a little less voltage right there. But it's doing 9.3 pretty steadily. So, in any case, that's the actual voltage it's providing, because we're telling it don't provide more than 5 milliamps of current. And so it's conducting so well that the power supply actually has to lower the voltage to limit the current right there. So that's another way that we could test the value of the Zener diode. Now we're going to do another quick test. I'm going to take the LED, because the LED, and we're going to improve it with the transistor coming up, the LED will light up when current is flowing. So we got to forward bias the LED. Anode, the long lead, to the red jumper. Cathode is down one row. And now we're going to add the Zener diode reverse bias. So their voltages are actually going to add up. It takes at least about 2 volts, sometimes close to 3 when current goes up, for a green LED to light up. And so it's probably about 2.5 volts at a minimum, approximately. So in any case, we got 10 volts. Again, we got current limited. That's really important for these tests, that current is limited. And so we got the LED, and we'll talk about this a little bit more coming up. So there you can see 12 volts, still less than 5 milliamps. We're at 3 milliamps. So when we get to trying to put 13 volts, current is limited. The power supply is not going to provide that much. So with this setup, right now it's kind of like a Zener diode, but at 12 volts basically, and a little bit more. So why are we doing this? We are limited to 20 milliamps for the LED and of current, and I'm not sure what the limit is for Zeners. Usually you don't put a ton of current through them. Maybe it can do 20 milliamps, but really we just want enough current going through it for it to set the voltage that we want. So now we're going to lower the voltage. So what we're going to do is take an NPN bipolar junction transistor. So I have here the 2N3904, and the flat side is facing us, 2N3904. That's the emitter to the left, base to the middle, collector to the right. If I turn it this way, emitter at the bottom, base in the middle, collector on top. So again, we're putting this directly to the power rail, and you can see that there is no current flowing right now. I'm going to take a 220 ohm resistor. That's because the transistor's off. Bipolar junction transistors are always naturally off. You have to turn them on with a small current from base to emitter. So we got the LED again. It has to be forward bias. Long lead the anode more positive, short lead the cathode. It's headed towards negative. We're going to reverse bias again the Zener diode and put that to the base. So we already saw it took pretty close to 12 volts, maybe slightly more, to get the LED and Zener diode to start conducting. and they lit up because that current was going through them. Now we're going to raise the voltage to about that point. So the LED is nowhere near as bright, and I think we are right where it's conducting. Yeah, it's at 5 milliamps, but it was holding 12 volts. Pretty much, slightly below. So we're pretty close to spot on. So now I go to 13 volts, and I have to up the current actually. So you can see the LED and the Zener are in series. Again, I don't want to put more than 20 milliamps of current through the LED, and that may be a lot for the Zener, I'm not sure, but the LED would be really bright if we were anywhere near even 5 milliamps of current. So I'm going to raise the current going through them, and you can see now we are up to 12 volts. Oh yeah, the power supply to 13. So now we're going up to, we're at 20 now. The LED, you know, it's got a slight glow right there. A little bit current has to go through the LED and the Zener, but the main thing is it's the transistor that is conducting that 20 milliamps of current. And so this has a limit, this transistor, of 200 milliamps of current, and it's also got a fair voltage across it. So right now it is passing 80 milliamps of current, and that's about where I'm going to hold it. I'm not going to try to fry it. So, and the LEDs lit up pretty good. You know what? I think I may smell some plastic burning. So that may have been more power than we should have did. But in any case, the main takeaway is the transistor can handle a lot more current, and so we just turn the transistor on with the LED and the Zener diode setting the voltage. So now I decided to grab my thermal camera, and hopefully we can see this. That really bright glow is actually the, looks horrible under that coloring. Let's try turning the lamp on. See if that helps. Yeah, that big fireball, that is the transistor. So it's a fireball. It's quite hot. And so we did go overboard on the current probably. So let's lower it to 40 milliamps of current right there. And so there's still a little current going through the LED and the Zener diode. And it's probably cooling down. So yeah, it looks like the temperature is cooling down according to that. Put my finger next to it. Still hot compared to my finger. And yeah, it looks like it's cooling down. I see 93 on there. This is not accurate though. There you can see. Let's yeah, there we go. We got 100. If we go lower, up higher, heat sensor must be down low. So like 180 degrees at 40 milliamps. That was the most I could get. And let's go to 80. Plus the LED is getting brighter. That kind of tells me, yeah, there's 190. We're already higher. 199. So yeah, it looks like it's going up in temperature. 200 right there. Yeah. So that's getting hot quicker. So yeah, I think the heat sensor must be a little bit lower than the thermal. So when you're farther away, I bet they line up a little bit better. So I'm guessing maybe we hit about the limit, and maybe we did a little bit of damage. Who knows? But in any case, that is it for this video. And make sure you watch the power ratings and everything. Limit current. This is not a, it's the 2N3904, not a high current component or a high power component. So probably a poor choice for transistor for this test. But again, we're testing things out. We're learning stuff. And so I'm going to keep it in the video. So thanks for watching. Check out one of these other videos and click the subscribe button. Make sure you click the bell so you catch all my other videos. Thanks for watching. I'll see you in the next video.